Greetings once again, students. Welcome to our second lesson on our financial computing course. Today we are going to learn about Microsoft Excel. We are going to look at cell referencing, how to use Excel inbuilt functions, how to use to create your own functions in Excel, the security in Excel, interfaces and validation in Excel, and also look at additional problem solving skills that we need to obtain in Excel as we get into our interactive sessions. Excel is made of inbuilt functions. These are found under the Formulas tab. You'd find that they are trig functions, math functions, finance functions. You all find them under the Formulas tab. And for you to be able to use any of the inbuilt functions, you need to type in first the equal sign and the function name. How do you get to know the function name? You have to use the F1 shortcut key, which gives you the inbuilt Excel help file. That help file, you can then search for usual functions that are used. More often, the name of the function describes what the function does. When you hover over the function name, there is a description of what the function does. For example, the function highlighted there, which is absolute, it's named ABS. It returns the absolute value of a number, that is the number without a sign. It means if I put in -10 as the parameter to that function, the answer will give me 10 because the ABS function removes the sign and gives me the absolute number. Using a function in an Excel spreadsheet is called calling a function. For those who do not have any appreciation of Excel, Excel is a spreadsheet which is made up of rows and columns. The rows are numbered 1 going down incrementally, whilst the columns are A, B, C, letters of the alphabet. To access what is called a cell, which is a box in Excel, you use column row pairs. A1 means I'm on column 1, row 1. A2 means I'm on column A, which is column 1, and row 2, and so on. Let us move on to cell referencing. Now that we know that Excel is made up of rows and columns, a cell is a combination of a row and a column, A1. And that A1 is the address of the cell, which is a reference which keeps whatsoever data we are dealing with at that point in time. So in Microsoft Excel, we have got relative cell referencing. This is the default type of referencing used by most users of Excel. To achieve this, as in our example, we use, first of all, we want to calculate the amount for each product sold based on the quantity sold and the unit price, which is basically a product of the quantity times the unit price. So we go on to cell D2, which is the column D, row 2, where we want to feed in our amount. We type in there, we say equals, and we click on B2. We put in our operator, which is a multiplication in this case, and we click on the cell C2. Once we press enter, we're able to drag down that column down to D5. It will automatically compute the amount sold for all the products, that is bread, butter, cheese, and ham. This kind of self-referencing is called relative cell referencing. Relative to where the formula has been put in, it's able to increment on its own and pick the next formula for the next row column combination. This is the default type of cell referencing. It helps us to fit in the formula on one cell, have it all propagated even to thousands and thousands of records. Imagine we're dealing with 10,000 products. In a button click, we'll be able to compute the amount sold for each product by just using the formula on D2, propagating it down using relative cell referencing. The next type of cell referencing in Microsoft Excel is called absolute cell referencing. Here, we are dealing with a constant value in a particular cell that we want to apply across a whole range of rows or columns, but it's going to be fixed. In this case of our example, we've got our conversion rate, which is fixed on column H3. We want to convert our length and our width from centimeters to inches. That means as we propagate our formula down from E3 to E6, we want to keep referencing H3. We do that by appending the $ before the cell address. In this case, instead of saying B3 times H3, we will then use the $ before the column H and the $ before the row 3. This is going to fix the formula going downwards to only change to B4 times the same constant on H3, B5 times the same constant on H3, and so on. This is called absolute cell referencing. Then we have what is called mixed cell referencing. This is a combination of relative and absolute cell referencing. When you want to fix either a row or a column by using the $ before either the column letter or the row number, you have to decide which one is going to be fixed and which one is going to be moving. The one that is fixed is the one that is appended by the $ before it. In the case of our example, we have B, column B, being fixed with the unit price for jeans. But the row 2 and 3 will have to change in the computation. And we also have the row 6. Row 6 has got the percentage reductions. We want it to be constant across all the computations, but we want our formula to be changing between column B, C, and D, so that it is able to pick the 20%, the 40%, and the 80%, which are the changes in the price reductions across the products in those months. So in this case, we have got a combination of absolute and relative cell referencing. In one side, we're fixing the column name, and the other end, we're fixing the row number. We shall move on to functions in Excel. We have got what are called logical functions. A logical function, it returns a Boolean value Boolean values are those that are either true or false. So the use of logical values in Excel is most associated with functions such as the if function, the and function, and the or function. We have to come up with decisions in solving a particular problem, which is generally how things are like in life. We do not have a one size fits all. We have certain conditions, e.g., if balance is less than 0, raise an alert, the account is in arrears. Or if due date has passed, then send a notification, the amount needs to be charged and interest. Those are the real conditions that we face in our day-to-day business operations, which are all conditional. So here you are testing if a particular condition is true or it's false, and you carry out the necessary process. This is how it is done in Microsoft Excel. We have got the if function. It starts with the word if, and what you put inside the open brackets are called the parameters. So the logical test is the condition that we want to be checked for. Then we separate the parameters that are needed in the function by commas. When you test a logical function, like a condition, we have got an answer which is true or false. So it means the next parameters that follow in there are what should you do if the output of that test is true, then you put another comma, and what should you do in the event that is false. This is the syntax of an if function. I would like you to reference the Excel spreadsheet and carry out the necessary examples under if statement. Let's move on to the end function. The end function, it checks more than one condition, and it will return true if all the conditions that are being tested are true, and false if any of the conditions are false. Let's suppose you've got a series of conditions to test for. If the account is in arrears, so you're checking if the balance is greater than 0, and you also want to check if one's due date for paying a loan has surpassed, and you also want to know if the client's age is above 30, then you can conclude that they are likely to be in default. So you would test for all those three conditions using an AND function in Excel, and then after that you can then have your value if the output is true or it is false. The OR function. On the other hand, the OR function checks for either of the conditions are true and returns false if all the conditions are false. So if any one of the conditions being tested for is true, then it has to return the process which follows a truth. Otherwise, if they are false, it has to return the process which follows a false output. There are cases where we need to have several if statements within an if statement because we are solving a complex problem. In this case, we use what are called nested ifs, where you've got an if statement within an if statement. Refer to the Excel spreadsheet with examples to solve these problems for a better understanding. Let's move on to sum and count functions. These are the most commonly used inbuilt functions in Excel. As we compute the sum, the totaling of certain figures, there could be sales figures, there could be marks for students. A lecturer wants to compute the average mark for a particular subject, or you are running your own business, you want to compute your gross sales. All these require the use of the sum or the count to know the number of products or items that we have sold in a particular time. In this case, you can use either the sum function or the count function to do these computations faster. The syntax is the function name and the values that need to be summed. These values can be cells. It can be A1, A2, A3 up to AN, depending on what you are working with. It can also be something on row 1. I'm just summing everything across row 1. You can do it in any direction, be it row-wise or column-wise. This works well with the sum function. Then we can have a conditional count and a conditional sum. These ones are named count if or sum if. There is a certain criteria that needs to be tested for. As we dealt with the if conditions, we also have them on counting. You could say, I want to count only those customers who have reached their maximum credit limit. Or I want to get all those customers who have bought more than 10 loaves of bread this morning. So the condition here is if number of loaves of bread sold is greater than 10, then count. Otherwise, don't count. You'd find that you'll find a lot of usage of this, especially in banking operations dealing with client account data. This is about the count ifs. This is where you've got many conditions to be tested for. So it's no longer if, but it's ifs with an S for plurality. This also applies to the sum function, where you're going to sum only a particular set of values because they meet a particular set of multiple conditions. Be clear to distinguish between count if and count ifs, sum if and sum ifs. And I encourage you to use the Excel spreadsheet given to you to try the examples under each. We have spoken about the sum function, spoken about the sum if function, and the sum ifs function, which are conditional summation. Let us go on to the Excel spreadsheet and try all the examples given. I'll end today's lesson at this stage. Thank you.